Hi everyone, I am Arathi Babu, Assistant Professor in Electronics and Communication from Mahaguru Institute of Technology. Today we are going to discuss about electrical analogous of mechanical translational system. We are considering an example for explaining the system. Okay, this is the example. Write the differential equation governing the mechanical system and draw its force voltage and force current analogous circuit. Okay, that means we are considering both force voltage and force current analogous circuit of a mechanical system. This is the circuit. Okay, for knowing the circuit, we have to know the basic elements in the circuit. The basic elements are mass M1 and M2. Okay, mainly there are three elements in a mechanical system. In a mechanical translation system, there will be three elements. These elements are mass, dashport, and a spring. Okay, here the mass M1 and M2 represents the mass of the mechanical system. Okay, here K1 and K2 represents the spring constant of the mechanical system. B1, B12 and B2 are the frictional force of the mechanical system. X1 and X2 represents the displacement of the system. Respectively, the B1 and B2 represents the velocity of the system. Okay, that means V1 is representing the velocity of mass M1, V2 is representing the velocity of mass M2. There is a force F of t that is applied on mass M1. Okay, here you may be in doubt why there is a representation B12. B12 means it is a frictional force between the mass M1 and M2. In other cases, that means B1 and B2, the friction is between the mass and some surface. It may be ground or any other surface. Here B12 and K1 represents the spring constant and frictional force between two masses. No other bodies is related in that thing. Okay, B12 and K1. Okay, so for representing the differential equation, first step is we have to draw the free body diagram. For drawing the free body diagram, first thing you have to know is that we have to find the nodes. Okay, nodes. Normally, node means we will be in a mechanical translational system, we may be considering mass as the node. Okay, in some diagram there may be mass may be missing. Okay, in that case the dashport in that circuit there may be a dashport and a spring may be connected. That means actually a node means it is a connecting point between any two elements that is representing a mechanical translational system. Here we have no problem, we have two distinguished nodes M1 and M2. The basic thing you have to know is that the number of nodes will be equal to the number of differential equation. Okay, so we are going to consider M1 for drawing the first free body diagram. Okay, we are using Newton's second law for this purpose. Okay, the force that are applied on mass M1 are the only forces F of t. Okay, then the other force that are applied by M1 are force due to K1, F of K1. Similarly, force due to dashport B12 and other forces force due to dashport B1. Okay, the force due to K1 and B12 is represented in another method. Okay, it may be represented for F of K1 will be equal to displacement. Okay, differential displacement in the sense F of K will be equal to F of K1 will be equal to K1 into X1 minus X2, where X1 is the displacement of mass M1 and X2 is the displacement of mass M2. Similar is the case for B12 also. There the force will be FB2 equal to FB12 is equal to B12 into d by dt of X1 minus X2. Here we are considering the differential velocity. Okay, the other forces are opposing force due to mass M1 and opposing force due to dashport B1. Then the opposing force due to mass M1 is represented by m into d square x1 by dt square. Similarly, the opposing force due to dashport B1 is represented by b into dx1 by dt. So now we can consider the free body diagram for mass M1. Okay, this is a free body diagram. Here we have to consider the node, whichever node we are considering, we have to represent that thing. That is, here it is M1. Okay, and all the forces that are applied on that node should be represented, and similarly all the opposing forces. From that we can write the differential equation. Here it is. What's in the differential equation? m1 d square x1 by dt square plus etc. This is shown here. Okay, this is written with the help of a Newton second law. Okay, similarly we have to consider the free body diagram for m2 and represent all the forces that are acting on the m2. Here there is no applied forces, so the representation will be, will be the representation? We are considering all the opposing forces, and all the opposing forces will be equal to 0. Okay, that means that here all which are the opposing forces? Force due to mass m2, force due to b2, force due to b12, force due to k1, and force due to k2. Okay, here one thing you have to note is that the force due to b12 and force due to k1. Okay, force due to b12, here we have to write it as b12 into d by dt of x2 minus x1, not x1 minus x2. Whichever node we are considering, we have to write that displacement of that node first and minus the displacement of the other node. Similarly is the case for k1 also. K1 is equal to the force due to, opposing force due to k1 will be equal to k1 into x2 minus x1, not x1 minus x2. Okay. Okay, so now we can consider the force voltage analogy. This is a basic chart which represents the force voltage analogy. Okay, in a mechanical system the input is force, so the analogous element in the electrical system is voltage. Okay, similarly output is a velocity in a mechanical system, and output is a current in an electrical system. Similarly, the dashboard in a mechanical system is represented by a resistor in the electrical system. Similarly, mass is represented by the inductor, and spring constant K is represented by a capacitor. Okay, these are the various representation in the force voltage analogy. So now we can consider the force voltage analogous circuit. Okay, this is representation for the force voltage analogous circuit. For representing this, you have to know some more basic ideas. Okay, the first thing is that the number of loops in an electrical system will be equal to the number of nodes in the mechanical system. That means here we have two nodes, that is M1 and M2. So there will be two loops in the electrical system. First row, roughly two closed loop in with the help of a pencil. Okay, next thing is that E of voltage is analogous to force. Okay, force in the mechanical system is analogous to voltage in the electrical system. So in the first loop, draw a voltage element. Okay, that will represent f of t in the mechanical system. Next thing you have to know is that the elements that are having the same velocity in the mechanical system will be having the same current in the electrical system. Okay, that means m1 b1, they are having the same velocity v1. Okay, then they will be having the same current in the electrical system. Though logically thinking, we can know that the elements which are having the same current in electrical system are in series. Okay, so you represent the analogous component of m1 and b1 in the electrical system. Which is the analogous component of mass? Inductor. Similarly, analogous component of dashpot is resistor. Okay, these two should have the same current. So we can know that they will be connected in series in the electrical circuit. The other thing is that in the checking the figure of the mechanical system, we know that these are not common to the node 2. So they will not be in the common branch. So represent these L1 and R1 in series in any other branch rather than the common branch. Okay, next consider the other elements. Which are the other elements? K1 and P12. C1, capacitor is analogous to K1 in the mechanical system, and similarly resistor is analogous to the dashboard. So checking the mechanical system, we can know that K1 and B12 is common to node M1 and M2. So in the electrical system, they will be in the common branch. So represent the analogous component of K1 and B12 in the common branch of the electrical system. Now check the node M2. Okay, that means loop 2 will be representing the node M2. Okay, here the various elements are K2, B2, M2, K1 and B12. We have represented K1 and B12 which are common to M1 and M2 in the common branch. So there is no need to represent once more. Okay, next is the individual elements, that is K2, B2 and M2. Okay, these elements are having the same velocity V2, so they should be connected in series. Okay, so connect these elements in series in any other branch rather than the common branch in loop 2. So by knowing these basic things, you can represent any of the electrical analogues of the mechanical system. So now we can move on to force current analogy. So for drawing the force current analogy, you have to know these basic things. Okay, these are the basic analogous element of the mechanical system. Force is analogous to current, velocity to voltage, dashport is analogous to resistor, same as force voltage analogy, mass is analogous to capacitor, and spring constant is analogous to the inductor. Okay, so in order to draw the force current analogy, you have to know some more basic ideas. The first thing is that the number of nodes in the electrical system should be equal to the number of nodes in the mechanical system. As shown in figure, we have two nodes. Look at the figure. Okay, we have two nodes in the mechanical system, that is M1 and M2. So we will be having two nodes in the electrical system. We are represented by capital V1 and V2. Okay, then connect all the elements that are connected between the two masses in the mechanical system as common elements between the two nodes in the electrical analogous circuit. The thing we have to consider is that the elements that are having the same velocity in the mechanical system should have same voltage in the electrical system. But when an element will be having same voltage, two elements will be having same voltage when they are connected in parallel. So connect these analogous element in parallel in between the nodes. Okay, that means we have to connect the analogous element of K1 and B12 in between the nodes V1 and V2 in parallel combination. Okay, then consider all the individual element corresponding to M1. Okay, here you have to connect all the individual elements, the analogous component of all the individual elements of M1 from the node V1 to the ground. That means the analogous component of mass is capacitor, B1 is resistor, and force is current. Okay, then connect this analogous component from node V1 to the ground. Similarly, connect all the elements of individual elements of mass M2 or node M2 from V2 to the ground. Okay, which is the analogous component of M2, C2. Similarly, the analogous component of K2 is L2. Okay, the analogous component of B2 is R2. Then connect this from V2 to the ground. Okay, then we will get the force current analogous circuit. This is much more simple than the force voltage analogy. Okay, thank you.